Okay, here's our last lesson on Pythagorean Theorem and our last lesson for Unit 3. So we will talk about the converse of the Pythagorean Theorem, which we've already talked about what converses are of proofs. So we're going to do the same thing with the Pythagorean Theorem. So far you have seen two different proofs of the Pythagorean Theorem, which states if the lengths of the leg of a right triangle are a and b, and the length of the hypotenuse is c, then a squared plus b squared equals c squared. This theorem also has a converse, which states if the lengths of the three sides of a triangle, a, b, and c, satisfy the equation c squared equals a squared plus b squared, then the triangle is a right triangle, and furthermore, the side of length c is opposite the right angle. So in our math journal, we're going to go ahead and write down this proof. We're going to assume that we are given a triangle ABC with sides of A, B, and C. We want to show that the angle ACB is a right angle. To do so, we will assume that angle ACB is not a right angle, which means that ACB is either greater than 90 degrees or less than 90 degrees. To make this shorter, we're only going to do the first case, or the second case actually, where ACB is less than 90 degrees, because the proof to do greater than 90 degrees is the same thing. So in the diagram below, or on the next screen, we're going to extend BC to a ray BC and let the perpendicular from A meet the ray at point D. So this is what it's going to look like. So go ahead and stop the video and sketch this diagram out with your ruler. Notice how A is being dropped down to a perpendicular and BC is extended so that A intersects BC at line D. We have this right angle here, but notice that's not part of our original triangle. So that's why this triangle that we're talking about is not a right triangle. So we're going to let M equal the side length of CD, and we're going to let N equal the side length of AD. So it looks like this. So by the Pythagorean theorem applied to triangle ACD, so ACD, so kind of this imaginary triangle that is not part of our original, and ABD, so ABD, which is the whole entire triangle, which includes both these triangles. Notice how this bigger triangle is a right triangle. But again, just like our square within a square, if we combine both of these, we're going to get b squared, which is b squared, equals m squared plus n squared, and applying the Pythagorean theorem to the other square, or the other triangle, we have c squared equals m plus, or a plus m, because remember this side length is comprised of a and m, so that's a plus m squared, and then we also have n squared here. So since we know what b squared and c squared are from the above equations, we can substitute those values into c squared equals a squared plus b squared to get, so here's our c squared, which is again referring to our original triangle, which is the grade in triangle. So c squared is equal to this expression right here, the a plus m squared plus n squared. A squared is a squared plus m squared, and b squared is the same as n squared. So now that we have that, since a plus m, going back to our proof of the Pythagorean theorem, if we simplify this out, we get a squared, or a plus m squared, which is a plus n times a plus m, which gives us our a squared plus am plus m squared, which simplifies to a squared plus 2am plus m squared. So now that we have that, we just plug that in. So the a squared plus 2am plus m squared plus n squared equals the a squared plus m squared plus n squared. So what we're going to do is we can subtract the terms a squared, m squared, and n squared from both sides of the equal sign. Notice that if we have the same thing on both sides, we can essentially take it out because they are equal to each other. So that's the case of a squared and a squared, m squared and m squared, and n squared and n squared. Well, if we do that, then we're left with this, the 2am, which is here, but then we have nothing on this side, which is a 0. Well, that can't happen because 2am has to be a length. We can't have a length of 0. Since we are coming up with 0, therefore our assumption that angle ACB is less than 90 degrees cannot be true. We can write a similar proof to show that the angle ACB is greater than 90 degrees, and that can't be true either because we would end up with the same thing. So therefore, the measure of angle ACB has to be 90 degrees because otherwise we wouldn't have this, we would have this part happening here. So let's take a look at example 1. The numbers in the diagram below indicate the units of length of each side of the triangle. Is this triangle shown to be a right triangle? So again, we're using the converse of the Pythagorean theorem. We're given the side lengths. We're given 610 as our hypotenuse and 272 and 546 as our leg lengths. But is this a right triangle? It might look in the picture that it is, but notice there's no square here, so we have to prove that it is or is not. So in order to find out, we need to put these numbers into the Pythagorean theorem. Recall that side C is always the longest side, so since 610 is the largest number, that needs to be representing side C in the Pythagorean theorem. To determine if this triangle is a right triangle, then we need to verify the computation. 272 squared plus 546 squared, is that equal to 610 squared? So finding the value of the left side of the equation, 272 squared plus 546 squared, and you're probably going to need your calculator for this. When we find that value, it is 372,100. Then you find the value of the right side of the equation, which is 610 squared, and when you multiply that, you get 372,100. Well, since the left side of the equation is equal to the right side of the equation, then we have a true statement. So what does that mean about our triangle? Well, it means that the triangle with side lengths of 272, 546, and 610 is a right triangle, because again, the Pythagorean theorem only works for right triangles. All right, here is example 2. The numbers indicate the unit lengths of each side of a triangle, so is this a right triangle? So what do we need to do to find out if this is a right triangle? Well, first we need to see if it makes a true statement when we replace A, B, and C with the numbers using the Pythagorean theorem. So how do you know which number is C? Well, the longest side is 12, therefore C has to be equal to 12. So go ahead and use your calculator to see if it makes a true statement. Make sure you show your work on your paper. So is this a right triangle? And make sure you explain whether it is or it's not. Your answer should have been no, it is not a right triangle, because if it were a right triangle, the equation 7 squared plus 9 squared would equal 12 squared, and that would be true. But the left side of the equation is equal to 130, and the right side of the equation is equal to 144. And obviously, since 130 is not equal to 144, then these lengths do not form a right triangle. Obviously, it's a scalene triangle, but it would not be a right triangle. So go ahead and complete exercise 1 and then check your answer by continuing the video. All right, for exercise 1, you should have come up with this answer. So the left side of the equation, if you set this up as 9 squared plus 12 squared equals 15 squared, is a true statement. The left side of the equation is equal to 225, and the right side of the equation is equal to 225. That means it's true, and the triangle shown is a right triangle. All right, go ahead and do exercises 2 through 7 in the same fashion, and then check your answers after you are done with 2 through 7. All right, this is what you should have. Go ahead and read the answers and stop the video if you need to, and then continue the video to see the rest of the answers. All right, here is 4, 5, and 6. Go ahead and stop the video if you need to, and then when you're ready to continue, go ahead and start. All right, and our last answer for number 7. Again, for any of these, if you have any questions, make sure you write the question down in your math journal or on the worksheet and bring them into class. All right, so let's wrap this up. We know the converse of the Pythagorean theorem states that if side lengths of a triangle, A, B, and C, satisfy the equation a squared plus b squared equals c squared, then the triangle is a right triangle. We know that if the side lengths of a triangle ABC do not satisfy a squared plus b squared equals c squared, then the triangle is not a right triangle. All right, we'll see you in class.